This video is about intersecting lines. So let's say that I have two lines here. So R is equal to some number A plus TP, then B plus UQ. Now, what we know is that, first of all, let's try to visualize what are the possibilities. Visualize what are the possibilities of two lines. So the first one is that either they are parallel, meaning, for example, this is your line 1, that is your line 2. So the possibility is that line 1 is parallel to line 2. Thus, they will never intersect. Okay, they will never cross with each other because they are always parallel. And how would you know whether they are parallel or not? You need to look at the direction of the first line. You need to look at the direction of the second line. And then you need to show that there is some number lambda, okay, that can actually make them equal with each other. So this is the way how you're gonna show it. What's the other possibility? The other possibility is that the two lines will intersect. So let's say that is your line 1, that is your line 2. The two lines will intersect. If they intersect, what does it mean? How shall we show that they intersect? We need to show, because the two lines intersect, then logically they meet at one point. They meet at a point. Only one point. It's impossible to be two, right? And they meet at a point. Thus, if they will meet a point, you can find the parameter t. You can find a t, okay, and a mu. You can find a t and a mu that will satisfy all the, or that will satisfy both lines, should we say. That will satisfy both lines. Both lines. Okay? So if there is a t and a mu that will satisfy both lines, then the lines intersect. Okay? Otherwise, the line is skew. Right? Skew meaning they will never intersect. Okay? So skew means they will not intersect and they are not parallel. Just for you to visualize it. So for example, you have here a box, right? I will just make it a little bit bigger. So we have there a box. And this line here, this line, okay? So that line and this line, okay, they are not parallel. They will never intersect. Therefore, they are skew. Okay? Because no matter what you do, whether you extend the line, they will never intersect. So guys, this is the summary on how to attack the questions in your exams. If the question says, show that they are parallel, then you need to show this one, that there is a lambda You look at the direction, and then there is a lambda that will make them equal with each other. Okay? However, there is also a possibility that they're actually the same line. So for example, you have a line 3, and the line 3 is actually passing through the line 1. In that case, they have the same direction, and actually they are the same line also. How would you know if they are the same line? Well, if it happens that these 2 points A and B, okay, are lying on that exactly parallel lines which happens to be the same. Okay? Now, for these to be able to get some what do you call this one, actual make sense, or let's create some examples. So let's say that I have line with the equation 5 1 negative 1 and plus t times 2 1 5, and you have there another line r is equal to 13 negative 6 2 plus mu times negative 3 4 1. Now, so let's try to find out whether these two will intersect, skew, or parallel. First, let's check, are they parallel? Let's say this is my line 1 and that is my line 2. Is line 1 parallel to line 2? How should we know? In your brain, in your mind, you check the directions. Okay? Check the directions. The direction of line 1 is 2 2 1 5. The direction of line 2 is negative 3 4 1. Then what did we say? You find some lambda that will make them equal with each other. If there is a lambda that can make them equal, then it is parallel. In this case, there is none. Okay, there is none. Therefore, what does it mean? That line 1 is not parallel with line 2. Okay? So that's the way how to analyze whether they're parallel or not. So if they are not parallel, the next thing to check is whether they are intersecting. Because if the line is not parallel, the lines are not intersecting, it means that the lines are skew. So let's take a look of the whether they will intersect or not. Again, what will be our thinking process to check whether line 1 intersect with line 2? In your brain, you need to show that is there a t or the mu that will satisfy both lines? If there is, they will intersect. If there is none, they will not. So just for you to imagine this is your line 1. Let's say this is the line 1. That is your line 1. Just an example. And then you have a line 2. So let's say this is your line 2. And let's say that this is your origin. That is your origin there. The 0, 0. Okay? Now, if these two lines intersect, then this one will be common to them. Okay? So we need, because the line 1, the direction is 215, and the direction of this is 215. The line 2, the direction is negative 341. Okay? Just for us to visualize. So we need to find this point of intersection. Specifically, we need to find this position vector. Okay? We need to find this so that we would be able to find this. Okay? So the position vector of that, and let's say that this is point P. That's the one that what we are looking for now. Okay? That point P. So again, how shall we know what is now our working equation? If they satisfy, they intersect, similar to what you have done in coordinate geometry, it means that the line 1, or symbolized by R1, is equal to R2. Let me just make this one R1, and let me make this as my R2. Right? Because this one will give you the method. This is the method. The method is, this is your aim, this is your target. The method is, make them equal with each other. Okay? So, let me make it here. So, again, let's make them equal with each other. It says, my line, or can I just erase this? No, but then you can, I might send this one to you if you want to. If you want the copy of this document. Alright, so the first line was, again, let's make R1 is equal to R2. So my R1 says 5, 1, negative 1. So 5, 1, negative 1 is equal to t, sorry, not equal to, but plus t times 215 is equal to, my R2 is 13, negative 6, 2, plus mu is equal to negative 3, 4, 1. Okay? So again, that is this part. That is this part. Alright? That is this method. So, again, our aim is to find the t and mu that will satisfy both of them. So how shall we do it? So we're going to break this down. So the next step is to break them down. Break them down into simultaneous equations. So you will have 5 plus 2t, that is this one, 5 plus 2t is equal to 13 minus, just be careful with the sign, minus 3 mu. Then the other one is 1 plus 1t, 1 plus t is equal to negative 6 plus 4 mu. And then this is negative 1, my handwriting is a little bit bad, plus 5t is equal to 2 plus mu. So let's transform this equation. So this first equation here can be transformed as what? 2t plus 3 mu is equal to 13 minus 5. So that is 8. Okay? Then this equation can be transformed into t minus 4 mu is equal to negative 7. And then this one can be transformed into 5t minus mu is equal to 3. So we have now three equations, equation 1, equation 2, equation 3. So again, we're going to find the t and the mu that will satisfy both of them. So let's try to multiply equation number 2 times 2, okay, times 2, and then equation 1 minus 2 times equation 2. Alright, so let me copy first the equation 1. So 2t plus 3 mu is equal to 8. Equation 2 multiplied by 2, you have 2t minus 8 mu is equal to negative 14. Again, the purpose of us multiplying them by 2 so that these two will be equal. So we can cancel both of them. So now we can, minus, okay, subtracting minus the 2. So you will have 2t minus 2t is 0. That is 0. 3 mu minus 8 mu is 11 mu. And then 8 minus negative 14 is 22. So therefore your mu equals 2. Okay? Now let's find the t. Let's use equation number 2. Because it says the t minus 4 mu equals negative 7. The t minus 4 mu, so that is what? 4 times 2 equals negative 7. So the t is equal to negative 7 plus 8. The t is equal to 1. So this is now your t. Now, what did we say a while ago? We need to show that this mu and t will satisfy equation 3. Again, this is the thinking process. Put this into your brain. If we plug in u equals 2, t equals 1 in equation 3, okay, and it satisfies what is the condition, what is the conclusion? Line 1 intersect line 2. If not satisfies, then it means L1 and L2 are skew. Okay, because there is no other possibility. So let us test that mu and the t in equation number 3. In equation 3, you have 5t minus mu is equal to your 3. If your mu is equal to 2 and your t is equal to 1, so this will be 5 times 1 minus 2 is equal to 3. So therefore, it satisfies. Therefore, the two lines intersect. Okay? But the next question is, where is the point of intersection? Where is the point of intersection? So you need to plug in either. So plug in the t in equation 1 or plug in the mu in equation 2. Why t in equation 1? Because your equation 1 is the one in terms of t. See? This is your equation 1, and it is in terms of t. This is your equation 2, and it is in terms of mu. Right? So let's try to find it out using the equation. Okay, why don't we just use both lines? So let me just rewrite the line. The line says R1 is equal to 5, 1 negative 1 plus T 215. Okay? If T is equal to 1, so let me just replace this one. If T is equal to 1, so what would it be? 5 plus 2 is 7. 1 plus 1 is 2. Negative 1 plus 5 is 4. So it is 7 to 4. 7, sorry, I said 4. So 7 to 4, right? Let's check with R2. R2 was equal to 13, negative 6, and 2, plus your mu is equal to plus mu times the direction negative 3, 4, 1. So let's replace the mu with 2. No. What is the mu? 2. Yeah, the mu is 2. So therefore that is 2. 13 plus negative 6. That is 7. Negative 6 plus 8. 2 times 4 is 8. That is 2. 2 plus 2, that is 4. As you can see from here, even you use equation 1 or equation 2, the answer will be the same. So before I give you another example, let's just try to review this one just to make sure that you understand. There are 3 possibilities for 2 lines. The first one is that they're parallel. So they're parallel if you can rewrite something, the direction of the first line and the direction of the second line, and you can make them equal by finding that lambda. The other one is that when they intersect. If they intersect, they meet at a certain point. So you need to find the position vector of that point from the origin. Please don't confuse yourself. My origin could be anywhere. Could be anywhere, okay? It depends on you, on where will you write your origin. Because remember, this is 3D, and 3D can be rotated, all right? And you need to find a t and a mu. That will satisfy both lines. If it's not being satisfied, then it is skew, right? So in this one, for example, what we have said, because we look at the direction of line 1, look at the direction of line 2, and there is no such lambda, therefore they are not parallel. However, for example, Mr. Daniel, what if the question is, give me an equation of the line that is parallel to R1? Well, as long as it has the same direction. So for example, I have my R3 is equal to 111 plus S times 215. See? The direction are the same with this one. So therefore, they are parallel with each other. Now, what about this? Does it have something to do? Well, the question is only parallel. So it's only a question of the direction. Any point will be okay, right? So, therefore, if they intersect as what we have said, the aim is to find a t and mu that will satisfy both of them, and the method is to make them equal with each other. Then you will get three equations which you need to solve simultaneously. Okay? After solving simultaneously, you will get the value of the t and the mu. Then you check with the equation number 3. If it satisfies, then they intersect. If there is none, then they do not intersect. For you to find the point of intersection, you need to use either equation 1 or equation 2, and then you plug in the parameter. When I say parameter, it is the letter that being used, the t and the mu. It is the letter that being used to define the line. So that's what do you mean by parameter. Okay? So hope you learned something with this. Basically, guys, everything just revolved around this example here. So you may look at some questions and try to do it by yourself. Exactly the same approach as what I have shown you in this example. Thank you very much.